All right. Last session of the conference. I really got to kill it, right? Keep everyone awake. Okay. So how many people, oh no, not you. Let me try this one more time. If my clicker goes, that'll ruin everything. It's gone. So how many people have seen this view, this user experience? Yes. So this is the Netflix web user experience. This is one of my favorite shows, Daredevil. Oh no. Yes, all right, cool. Oh, you ruined my reveal. It's okay. So this is the experience that we have right now, and this is how most people around the world experience Netflix through our streaming platform. Show of hands, how many people have seen this or even gotten one of these? Okay. So this is how Netflix started. We started off in the late 90s as a DVD by mail service. How many people knew that? Okay, all right, good. And so this is our legacy. Netflix has been around for 15, 18 years, something like that, even longer. And so we're a fairly old tech company. And in the beginning, we didn't start off in the cloud. We started off in a data center, building a monolithic Java application, just like many of you probably have built in the past, and I have as well, built on top of Oracle. And as we grew as a company, and as we moved into streaming, we evolved. We started moving into AWS, microservices. We moved from Oracle to NoSQL. And this is probably a story you've heard many times, and don't worry, I won't tell you more than that. But the key part of the story that didn't change was that we were always a Java shop. And that was a part of our legacy that we carried with us. Java worked very well, it scales very well, even in the cloud. And this was part of this is part of who we are as a company until recently. And so that's what I want to talk about today. I want to talk about this rise of Polyglot at Netflix. And I don't know how many people have never heard the word polyglot, but polyglot just means multiple languages and being able to embrace multiple languages. So in order to understand this rise of Polyglot at Netflix, we have to start off with understanding what is it like to be a Java application at Netflix? What is it, as a Java developer, what are you exposed to? And so there are teams like my team at Netflix, which is the developer productivity team, which our job is to build tools to enable you as an engineer to be effective. And so my team happens to be playing in the space of build and deployment, specifically around build. But there's a runtime team, and their job is to build libraries that, like the ones I talked about yesterday in the keynote, but these libraries are responsible for making sure that your service is performant and reliable at runtime. There's a monitoring team, they build monitoring tools. There's a security team, they build tools to secure the JVM and the instances as it's running in the cloud and to scan and monitor them. There's a performance team that builds tools around getting details and information out of your JVM. Has anyone ever seen a flame graph before? Okay, so we're lucky enough to have Brendan Gregg working at Netflix, but that's an example of the work that the performance team does to help the JVM be performant for Netflix. And we even have very niche things like a failure injection framework. I was talking to someone about this earlier today, and that actually injects bad requests into our runtime to test the resilience of our services. All of these functions, all these tools, frameworks, are built around the premise of running on Java and the JVM. And so I'm not an expert in any of these things except for the build and deploy, so we're going to focus a lot just on the build and deploy aspect of what it's like to build a service at Netflix and to operate it. No one fall asleep, including me. I hear snoring. So how do Netflix engineers push code? Well, there's three real basic steps here. The first one is you need to build your code, and my team, being responsible for the build stage, provides tooling on top of Gradle. You have to bake your code. And baking is a term we use which merely means turning your application into an immutable server. And this idea of immutable servers is a basic premise of Netflix's deployment infrastructure, which means we never touch code running on an instance. If you change a line of code, you don't go to the instance that's running. You change a line of code, we create a new VM for you and deploy that into the cloud and throw out the old one. Your servers are immutable. We call that baking. And then you deploy, and our deployment tool is Spinnaker. And so visualize another way, we call this our paved road. And our paved road uses a bunch of tools throughout this process. And so whenever we talk about deployments at Netflix, building code at Netflix, this is the basic premise. This is the contract that the build and deployment team, which is engineering tools at Netflix, has with our customers. Is that if you use Nebula, Jenkins, and Artifactory, the Bakery, and Spinnaker, we're going to enable you to build and deploy to the cloud rapidly and repeatedly. And if you have problems, we're going to help you. So specifically, when we start talking about building and deploying, my team built tools on top of Gradle called Nebula. And specifically, we have a plugin in Nebula called OS Package. So OS Package is responsible for converting your Java application into a Debian file. This Debian is the input into the baking process. And this is open source, by the way. If you can go to nebula-plugins.github.io. And play with all the plugins we have, including OS Package. And so if you look at a build.gradle file, and this is a complete Java build.gradle file, you're going to see for OS Package, specifically, you're going to see that we added the parts I highlighted in blue are OS Package include statements, and the part in red is the important bit. And so I'll highlight that. So this right here is a definition inside of a build.gradle of how I turn my Java application into a Debian package. And so I'll run through it real quick. So the first bit right here, I'm defining the packages, the OS level packages that my application requires whenever it gets installed on a machine. In this case, Java and Tomcat. This part right here, this pre-install, allows me to tell basically the app when it installs. Before you do that, just remove Tomcat's root application right there, because I'm gonna use that space. So just remove it. And then right here, this from war, the war task. So Gradle has this concept of tasks, and tasks in Gradle have inputs and outputs. What we're saying when we say from war is we're saying take the output of the war task, which is producing our application, and install it into the local directory of web apps on the instance whenever you install my Debian on an application, and then just rename that to root.war. In essence, this will give me everything I need to stand up an application on Tomcat that's installed on an instance. Arguably, I shouldn't need anything else more than this to install an application in the cloud. And so most builds at Netflix look something like this, right? This is an oversimplified version, but something like this. And so let's talk about the non-Java story now that we kind of have an understanding of what Java looks like at Netflix. So this chart shows the number of projects at Netflix that have grown over the past, since 2010, split out by language. So you can see here we have, this is Java or JVM languages growing, the number of projects. And so you would expect that to be the predominant volume of projects. And these are all Git repositories. From here, we have also JavaScript and Python. So in the last couple years, we've started to have this significant rise in not only just the number of projects, but also JavaScript and Python in particular. And so our team has not been ignorant to this rise. We've seen a lot more requests in our support channels about how can I get my Python app or my JavaScript app, and even things like Golang. And so we had an answer for them. When a Node.js developer came to us, we said, hey, we got an answer for you. All you need to do is turn your Node.js application into a deb, and once it's a deb, you can bake it, and everything looks the same from there. And here's how you do that. So here would be the build.gradle file for a Node.js package or project. So we require a different library right here, which is the platform sidecar. And the platform sidecar is a sidecar process that allows a Node.js application to participate in all the Netflix ecosystem. It's basically a JVM instance that runs on the side. You can make local host HTTP calls, and it has all the client jars embedded in it, and allow you to participate in things like Eureka and everything else. You take the output of the dist directory and you put it into Apache, and then you just turn off Tomcat and enable Apache, and you're good to go. And so we felt great. We helped these Node.js developers, and we did it in like a way that scaled for us because we were reusing our tools. So it just worked, right? No complaints. Well, how many people here are JavaScript developers? Okay. How many people here have installed Java and keep up Java up to date on your machine? JavaScript developers, sorry. So the first complaint we got was, I'm a JavaScript developer. I don't want to use Gradle. I don't want to install Java. Why do I have to use this thing called Gradle? And initially, we very much dismissed this, right? Because we're saying, you know, you're at Netflix. We're a Java shop. You want to use Node.js. We have this culture of freedom and responsibility, which means you want more freedom. You want the freedom to choose a different platform, which means you also take your responsibility. And you actually take on more responsibility to manage your process on your own. Let us know if you want to write your own Debian packager in Node.js, and you know, we would love to see how that works. And so this worked for a while, and then we reached a tipping point. And this tipping point was when a project at Netflix, a team at Netflix, decided that they wanted to move away from Java, and they wanted to rewrite their whole stack in JavaScript, in Node.js in particular. And this was a significant portion of the runtime at Netflix. And so what this led us to do is realize we couldn't keep providing a solution that Node.js developers really didn't like, and we had to kind of go back to the drawing board and rethink our solution. We had to provide a way, at minimum, to produce Node.js Debians using what we considered native tools. And so our first approach was probably the one that most Java developers would take, which is we have Nebula. Nebula has an OS package. It works great. Let's just replicate this pattern. Let's take Node.js's build tools and let's pick the best one and let's write OS package for Node.js. So for those hands that went up, JavaScript developers, you may be laughing to yourself right now because I said something. Pick the best JavaScript build tool. Our naive Java developer minds discovered this. This is the small window of ecosystem of the JavaScript build tools. We found at least one project using one of these build tools. What also surprised us is that we found multiple projects that use multiple versions, multiple of these build tools. I found a project that used NPM. Well, most of them used NPM anyway, but they use NPM to pull down their packages, and then they use Gulp for a portion of their build, and then they wanted to also use Webpack for another portion of their build. So we're left with this feeling like, okay, we can't take the same approach with Nebula, right? We can't build something native inside JavaScript. It's just not going to work. Because forcing JavaScript developers to choose one build tool was just not going to work because A, it depended on which month it was their favorite build tool. and that's not disparaging, it's just the state of the JavaScript community, right? They change very rapidly. In fact, we were in a meeting with the Node.js team that was converting, and in that meeting, the #1 hit on Hacker News was Broccoli.js. It had just been released, I think, that day or been talked about. And so it was kind of this laughable moment where we're like, okay, we can't take this approach. So we decided that we needed to make something that was actually not just that would work for JavaScript, it also had to be language agnostic. JavaScript was just the first of many. I showed you that Python was also on the rise, and I'm sure there's other languages that were in our future. So we had to think about how can we solve this problem in a way that scales with the growth of different languages, right? And going back to this problem that JavaScript developers, this feedback they gave us, which was we wanted the solution to feel native, so that they felt like they were still operating in their ecosystem, in their environment, without going out and using a Java tool or a tool outside of their ecosystem. And so we landed on this concept of not building a build tool, but really we needed to define a workflow abstraction on top of how developers work locally on their machine. And so from that, Newt was born. And so Newt is a tool. I'm going to spend the rest of the time talking about what Newt is and how we went about building, or how Newt solves the problems. But it's essentially a workflow toolkit for solving all of the JavaScript, Node.js, and also our Polyglots problems at Netflix. And so our starting point for choosing a language was to choose Go. And so you've heard a lot about Go at this conference. There's been a couple of talks that either mentioned Go. But there were two reasons we chose Go for building the solution. So we wanted Newt, we wanted it to build it as a command line tool so that you can run it locally, we can run it on build servers. And we chose Go for two reasons. One, when I create a binary, an executable with Go, it's a static, self-contained binary. I can give it to anyone in this room and it has no dependencies, which makes installation extremely easy. And then two, from my Mac, I can cross-compile versions of a Golang application that work on FreeBSD, on Windows, on Linux, on Mac, and I don't need a whole build farm of different machines that need to compile it down natively. These two features of Go, I would argue for our case, especially for command line tools, make it a killer platform for building. Now, the developers on my team don't love the language itself, but that's okay because they recognize that these two features are well worth the cost, any costs they have in the language itself. So we went about building Newt to solve the Node.js problem, knowing that we were eventually going to solve a number of problems down the road. And so I'm going to talk about kind of some of the problems we tackled and how we tackled them and our solutions with Newt. And the first one is this problem we started with, which is how do I produce a Debian in Newt? And so Newt has this concept of commands. And so here I'm showing running the Newt build command. So the Newt package command. And so we're first checking the build directory on my local machine, and it's empty. And then I run Newt package within a project. And this project is called Picardbot. And anyone who watches Star Trek will know that when it's running, it's actually called Locutus, inside joke. And so what it's doing right here is it's doing two things. The first thing you'll notice, well, I'll show you the output in a second, but there's the output of the directory. So we can prove that we just built in the build directory a Debian. What it did is two things. The first thing Newt package did is it pulled down a Docker container. And inside that Docker container is Java, Gradle, and OS package with a standard build.gradle file for JavaScript. We've essentially provided a containerized environment so JavaScript developers don't need to install Java on their local machine, and we're able to reuse our functionality. So this was beautiful. No one complains about this anymore, so they can just run Newt package and it just works. So the advantage for us was that now we can reuse our code and Node.js developers don't need to even see or Gradle other than the output right there. And that was sufficient for us. But this solution of using Docker to package up Newt, or use Docker to package up Nebula and Java, produced a second problem, which is now I need Docker, right? So the solution here was Newt provides us this concept of a Newt setup. And so what Newt will do is you can run the Newt setup command inside of a project and it will detect which dependencies that you need on your local machine. So in this instance right here, this project defined that Newt requires Xcode, Homebrew, Git, Docker, Docker machine, VirtualBox, and Node. And so it's checking that not only these tools exist on the path, but the right version of these tools exist. So this allowed us to ensure that all developers could be on a consistent runtime platform for every single Newt execution. Great. And so the way we did this is we introduced this concept into Newt of app types. So an app type was, in this case, the app type was called Node Beta. At the time, it was in beta, our Node app type. And it's built into, you can see, it's in a .newt YAML file. Those of you who've used Travis CI or some other tool like that will kind of recognize this pattern of just using a YAML file to define your build. But what it allows us to do is that app type has an externalized definition of what the configuration is needed, what's needed to install. So whenever Newt runs in a directory and it detects a Newt YAML file, when you run setup, it will then go out to grab the configuration for that node app, this app type, which is Node Beta, download the configuration, and download all the dependencies. So now, as a Node.js developer, I have my environment I can package up, but I want to build. So we had to introduce another concept into Newt, which is the concept of a build command. And the way we handle this is reusing the Newt app type, or the YAML file. we just added a build step. And this is also very similar to a lot of build tools you see out there. In this case, and I'm not a Node.js expert, but in this case, the npm run script command is what we're using to build this application. And so when we run Newt build, what it's actually doing inside of the package.json is running npm install ESLint, which is a lint tool for ECMAScript, which is JavaScript, and then it's running npm test. So this would be a very typical build for an npm developer, or at least ones that I've encountered at Netlfix. Results may vary. And this allowed them to, inside Newt, to understand how to build their project before it packaged. So now you can run Newt build, package, and it would package up your app, build your application, test it, and then package it up. But in doing so, in doing this, we solved most of these problems that Node.js developers told us about another problem they had, which was when they're building locally, they have one version of npm in Node.js. When they build in Jenkins, they have a different version of npm in Node.js. And then when they actually deploy on the base Amazon machine image that we provide, it provides a third and different version of npm in Node.js. And so this problem of these environments being consistent was another problem we wanted to solve with Newt. And so we went about adding another section to the Newt YAML called tool versions. And so in this case, we're adding just tool versions for Node and npm. And we can define those right there. And then in order to make this work, we're going to introduce another concept into Newt that allows Newt to understand how to bootstrap this application. And it's this idea of the Newt exec. Now this pattern also we stole from, anyone done Ruby? Used like something like Ruby bundler? So this will seem very familiar to you. The Newt exec command is essentially it allows me to run a command within a containerized environment. So when I run Newt exec, what that Newt exec command is going to do is first going to say, do I see a Newt.yaml file? If I do, does it have any tool versions? If it does, I'm going to make sure these tool versions are available and on the path, and then I'm going to execute the command following with those versions on the path. And so now what we can do is we can guarantee that whenever someone runs an npm command with Newt exec and a YAML file, they're always guaranteed to get the same versions of Node and npm in their path. Showing how this might look, on my machine, I ran npm versions on the right over here, and then Newt exec npm versions. And you can see that this is going to spit out just a JSON file of the versions. Over here, I have a different version of npm on my local machine, which, if you learned anything from my keynote, transitive dependencies, blah, 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 different environment, look at all these different dependencies over here. So even on my local machine, even in the, upgrading from npm 3.10.8 to 3.10.10 and providing a different environment, I get some deltas in my build. So this provided a benefit to the Node.js developers at Netlfix, because we can now guarantee that their environment's always going to have the right dependencies. But this introduced another small challenge, which is now as a Node.js developer, I need to run Newt exec npm every single time I run npm. Well, the good thing is there's just an easy way to fix that, right? You just alias npm to Newt exec npm. And the beauty of this is Newt exec is effectively a pass-through command, so they don't need to worry about the side effects of Newt. If Newt exec doesn't detect a .Newt YAML file, it's just going to go ahead and run the command without any container. And so now their muscle memory of running npm whatever is going to execute Newt always on their local machine. And so now the advantage there for a developer is that they no longer have to think about, I have to switch my behavior. And this happens a lot. Like you copy a command off the internet or you want to run something off a doc, they can just follow those instructions, and we're always going to ensure that Newt's going to keep their environment up to date. So for Newt, these are the basic commands and basic functions we added into Newt. A little bit beyond Newt, we also added a project creation process. So we call that Newt init. And what this allows, using the app types, we can provide these definitions. So I can create a Newt, I can say Newt init app type node. It's going to walk me through a series of questions like, what's the name of your app? Where do you want this stored in Stash? Where do you want this in Jenkins? And it's going to create my project locally. It's going to create a Stash repo. It's going to create a Jenkins job. It's going to create everything in Spinnaker, so I have an application. So I can basically get up and running with a standardized project in the matter of minutes and be pushing code and deploying. We also started using it for our Titus cloud. So Titus is the Docker cloud that we use at Netflix. Or, sorry, container cloud, even though it says Docker up there. It's really more of our container cloud. And in working with the Titus team, we've been working to make sure that Newt is the command line tool that allows everyone at Netflix to use Titus as a first-class citizen. So they can start using, building app types for Titus and deploying those into the cloud. It also, Newt allows them to spin up a local Docker environment. And Newt has a first-class understanding of Docker. So we are going to use that for making it easy to run localized tests, building on the work we did with Newt's app, the Nebula app type. Downloading Nebula. We can use Docker to containerize builds, containerize local tests, things you've heard about being used for Docker, the value of Docker in the past. So I ran through this pretty quickly. I want to leave you with some parting thoughts on kind of our lessons learned on going through a polyglot evolution. So the first one is really hide complexity. And I think this is a great use case for Docker. We've gotten, you can see we were able to reuse a lot of the complexity of Nebula and put it inside a Docker container and give it to all our developers with very little headaches on our end. And then what we end up doing is also developing some abstractions on top of our workflow. Rather than understanding the differences in how JavaScript developers think and Java developers think, we started thinking about what are the general abstractions we want in our development processes, and can we model that inside of a tool and then provide those abstractions to every single environment in a very unique way. And there's tremendous value in considering using native or native-like solutions to allow developers to feel like they're staying within their ecosystem and their environment. As we start rolling Newt out to other languages, we started making it available for Ruby. We started making it work more closely with Nebula so that Java developers can get benefits from this. We want to maintain this idea that they're still staying within their ecosystem without feeling like they're exiting out, and Newt can help with that. And then there's kind of a cautionary tale for going polyglot, which is that first-class support can suffer. And what I mean by that is, in the Java world, our team built Nebula, which is a Java-based build tool. We spent a lot of time thinking about Java dependency management, scaling up dependencies in the JVM, and we have deep knowledge of Java and builds and dependency management. You can see in this approach, we've taken a different view, which is we've said we're not going to have deep, strong opinions about this. We're going to take a high-level opinion. And so what we end up doing is by allowing our team to scale horizontally with the diversity of needs, we're actually bringing the level of support up for every single language, which means that we don't have deep support for JavaScript anymore. Or we won't be able to provide deep support for JavaScript, which means that team's going to have to take on that responsibility for themselves. This is something to think about when you start, if you're considering supporting multiple languages in your environment. And I think really the way I would think about this is this polyglot can be much more expensive. While it can be frustrating for developers at the time, it's much easier to stay on one platform and one language and be able to scale it up and do that right. And then later on, you can move on to something else. And that's it. Thank you. So you guys are free to go, or you can ask me questions.
When are you going to open source it?
Yes, the first question. I don't know why I don't put a first slide up there that says when I'm going to open source whatever I'm going to talk about. So the engineers on my team for a long time, and this is a general rule, like I've talked about a lot of tools. If they're not open source already, we either have talked about it or essentially the engineers on my team, they're the ones going to be responsible for dealing with the cost of open source, and we have recognized, especially through Spinnaker and Nebula, that open source is not free, right? It's another queue of support issues. So the team, for a long time, has focused on building the tool internally and then figuring out later how we can whether or not we want to open source it. And only recently have they talked about open sourcing it. So I don't have a date, but maybe sometime this year the team is actually interested in open sourcing it. I know that the one thing they don't want to open source is the setup command, because they basically don't want to deal with everybody's Windows install setup command issues, right? So I think that's one area of concern, that we don't want to replicate the challenges of supporting, Chef, Puppet, Ansible style setups across the globe, but everything else we feel like could be useful. So.
What about Java? Are you using Newt or better?
We're not using Newt right now. Actually, we just added an app type for generating Java projects. But after that, there's not really any use for Newt. And what we've tried to figure out is what's the relationship now going to be between Newt and Nebula? Because you have Nebula sitting here in Gradle, and where it gets interesting is OS package is a functionality we've proven that was built for Java that is is abstracting up to all languages. We thought that was the only one we'd need. We realized there's a couple other functions in Nebula. Like one is the Nebula release plugin, which allows us to tag releases, tag branches, and say, this is a major release, so release this. That's a function that the Node.js developers want, Ruby developers want. So we're probably going to pull that up into Newt. And as we start pulling more features up into Newt out of Nebula, we'll probably start to Nebula will look more and more like just maybe a Java dependency management tool than just a universal tool, which is where it's been. Does that make sense? Yeah. But I think the story will happen organically over time.
Why use Debian as a packaging format and not just use Docker as a generic way of just packaging anything and then
Right.
exporting in HTTP?
No, it's a good question. So this process of baking goes back to our first days in the cloud. So this is 2008, 2009. Is when we started doing this. And so now we have a robust infrastructure to do this and handle this. You are right that the idea of using Docker to build a package is actually something we talk about a lot. The question we have is, what is the advantages we're getting by switching, right? The switching cost is actually the big thing. If I was starting today, that's where I would go. But, and you get other advantages as well, so. Maybe eventually we'll switch, but right now what we have is this world where as Docker becomes a bigger thing in our container cloud, Newt is able to package up Docker containers. So we actually have this deviation in how you package. And so it might make sense that now as the Docker container world maybe gets bigger, it might make sense to just make everything a Docker container, even if we're deploying to an EC2. So the impact there is if you're deploying to EC2, and you have a single node instance, do you want a Docker install, to Docker run to be part of your EC2 instance in your cloud? Versus, you're adding another more complexity into something that's never going to take advantage of Docker other than for packaging. So, it's a good question.
What do you do with client libraries? Do you write them in multiple languages?
So, can you say that one more time? Sorry.
Client libraries.
Uh,
Multiple languages or just a single language?
It's a good question. I've historically, no, only one language, Java, which is why I talked about for JavaScript. So if I was building a JavaScript application and all the other services in Netflix are written in Java and they have their client jars, the approach that we've historically took was to add, you declare the sidecar, which I talked about a little bit, and that sidecar then is a Java application that runs next to your Node app, and it has the client jars in there. And then you would make local calls to that instance, local HTTP calls, and then it would farm out those client jar calls. I think there's some talk and experimentation around gRPC, and maybe potentially building client jars in multiple languages, but that's not my team's purview per se. But I'm not sure if that's going to be the future or what. So. Correct. Yeah. Yeah, so they're not going to produce a client jar for their service. So the teams that have chosen to go off what we consider the paved road, and not just for deploying, but for runtime, if your app is running in Netflix and is part of a critical streaming service, which means it's part of that user interface that you see, we strongly recommend that be in Java, because you get all the advantages that I talked about in that tooling ecosystem. So we saw a lot of JavaScript in teams that are outside of that tooling ecosystem, but that don't need necessarily that client jar environment, like our content team, for instance, that does a lot of processing of content coming from studios. They build a lot of stuff in Node.js. The tipping point I mentioned was we started building a lot of our, there's a team that builds part of our front-end API that doesn't necessarily need to take advantage of client jars. They decided to move to a Node.js Docker-based solution, and that was a significant portion of our fleet. And so that was enough for us to say we need to change our support model. But still no client jars for JavaScript right now. Any other questions?
Teams in Netflix are polyglots. So what is the debate to choose one language or another before starting a project? Is there some kind of debate inside the teams, or you have a JavaScript team and a Java?
I think it's definitely team specific. So the question being, what does it look like when you start a project? Is there a debate about what language to use? I think, I'm going to keep quoting this freedom and responsibility. The team has to ask themselves the question, right? If we want to deviate from what's quote unquote supported by all these central teams, we have to choose to take on more responsibility, right? So if I tomorrow chose to build an app in, I don't know, name some in Perl, or a service in Perl. I'm not saying Perl's bad, but if you decided to build a service in Perl, I would have to figure out all the different ways of packaging that up, putting it in a Debian. I'd have to figure out how to make HTTP calls. I'd have to do everything that I needed to do that we consider a service good. And the more critical that service, the higher that bar gets raised, and the more work I have to do. And at some point, you're just like, I just wanted to build a service to do X. Might as well do it in Java because that's what the most of our ecosystem supports. It doesn't make, and you can do it, you can make the argument, but generally speaking, it doesn't make good sense. Because, so another part of our culture is we hire people that make, a value we have is judgment, right? And I think given the right context, an engineer would say, well, it doesn't make sense for me to do anything but Java at this point. So, one more question?
In your Titus cloud, do you use some sort of container orchestrator or something?
Yes, and like I said, I'm not certain how all that stuff works, and it's only because I know that Andrew Spiker has talked about this a couple times. He's put out a tech blog post on Titus. He's given some talks, so if you search Netflix Titus, you will find some artifacts he's left on the internet about how Titus works. And I know it's evolved over time. It used to be called Titan, and now it's Titus, so I would defer to that for sure. But yeah, they're definitely using some kind of orchestrator, but yeah. All right, if you have any more questions, I will stick around, but thank you very much.